Chapter 14, solutions. Unfortunately, these are chemical solutions and not solutions to your problems. Okay, thirsty solutions, why you shouldn't drink seawater. I think everybody knows you shouldn't drink seawater. If for no other reason, it tastes horrible, right? Crazy, crazy salty. But you sometimes hear about people that, get stranded at sea and they're desperately thirsty, and it can be tempting because you're surrounded by water, but not a drop to drink.
Quick question for you then.
Yeah.
With that, besides the drinking it or whatnot, doesn't the saltiness help with buoyancy?
It does. Yeah. So the salt in the ocean does make your body a little more buoyant because it increases the density of the water. And I've never had a chance to do this, but I hear that if you go swimming in the Great Salt Lake in Utah, that is super, super salty, right? And you actually notice how much more floaty you are. Yeah. So seawater actually will draw water out of your body as it passes through. So you can think of it as a thirsty solution. It's pulling water out. So it's actually better to not drink anything. Drinking seawater will get you more dehydrated than before. Seawater is a solution, which is a homogeneous mixture of two or more substances. And we have talked about solutions before. So in seawater, water is the solvent. That's the major component. Sodium chloride is the primary solute. And then there's a lot of other ionic compounds that are also dissolved. Potassium compounds and magnesium, and there's lots of different salts in there. And that's why if you buy sea salt at the grocery store as opposed to regular salt, it does have a different taste to it. So here's an illustration of seawater. So we've got lots of water molecules and some ions floating around. Nature has a tendency towards spontaneous mixing unless the energetics are extremely against it. So if we think about, say, this kind of looks to me like a fish tank with a barrier in the middle, a removable barrier, and we've got fresh water on one side and we've got salty water on the other side. If I pull this barrier out, and pull it out super, super carefully so I don't cause any swishing around or mixing or anything, will the seawater just stay on its side? No. It may take a while, but eventually it will all mix together spontaneously. If you drink seawater, this tendency towards mixing will cause a flow of solvent out of your cells and into the seawater. So here's your stomach, and coming down here into your intestines. Interesting thought. Your stomach is actually outside your body, right? Because we're kind of like a donut. There's a hole going through us, right? So the stomach isn't really inside your body. It's outside. We could argue about that. So here we have the stomach or intestinal contents, and here we have your body. And there's cell membranes that keep all the stuff in your cells together. Those are permeable to a lot of different ions. And they need to be, otherwise you couldn't absorb things from your food, right? So as this concentrated salt water comes through here, the water in your cells has a lower salt content than the seawater that you've been drinking. And so nature's tendency towards mixing says that water molecules will pass across this membrane, basically in an attempt to make both sides the same concentration. Does that make sense?